Good morning, doctor. I'm Ruyi from Group 10, and now I would like to explaining our project, which is the direct recording electronic voting machine. In this assignment, our objective is to design and implement a voting system using an AVR microcontroller and an LCD display that allows users to cast vote for 4 different candidates and display the vote counts in real time. And the below is show the component used during the hardware prototype, which consists of microcontroller, LCD display, push button, and the port used. And now I would like to explaining about the overflow of our project, which is before we start our voting system, we need to initialize the microcontroller. The microcontroller ports like port A, port B, port D are configured. Port A and port D are set as output ports to communicate with the LCD display, while port B is set as an input port to receive signal from push button used for voting. The next one is the LCD setup. Commands are sent to the LCD using functions like send a command function and send a character function. This command will control what the LCD displays by positioning the cursor and sending characters or commands. And the next one is the main loop. The program will enter a main loop where it waits for the user input to start the voting process. Initially, it displays a message on the LCD and prompting the user to press any key to begin. And the next one is the voting process. When the voting starts, the program will continuously monitor the button connected and detect the vote for candidates. Each button pressed will increment a respective vote counter, which is the count A, count B, count C, and count D, and it will update a total vote counter, which is T. After each vote, the update LCD function is called to refresh the LCD display with the latest vote counts. It converts the numeric counts into string using the ITOA function, which is predefined in the library. Then users send a string function to update the LCD with this value. And after the end of the voting, a designated button like the sum button is pressed. Then the program will stop counting the new vote and display the final tally for each candidate and the total votes on the LCD. And the last one is the debugging and monitoring. During the development in ML Studio, developer can monitor and debug the program execution. They can check the processor register, memory contents, and the I/O operation to ensure the program behaves correctly and efficiently. And now I would like to move on to the simulation circuit in Simulite. And for our simulation circuit in Simulite, which consists of resistor, capacitor, push button, and Mega32, and the last one is the LCD screen, which shown in the figure above. And following is the hardware prototype. And the picture above showing our hardware prototype, which is built by our groupmate Sun Yi. And so let us continue to the simulation using the Simulite. When the simulation is on, the LCD screen will display a welcome message. The button ABCD can be pressed randomly except for the button reset and sum to start the system. The voting system is operating by pressing each button and the T value in LCD screen is incremental whenever a button is being pressed. When the voting is done, pressing the button sum and the overall result will be displayed through the LCD screen. Reset button is pressed for the next voting process, and the LCD screen will display the welcome message again. The next round of voting process will continue. And it's time for the hardware implementation. The voting machine will start when the microcontroller is on and pressing any button except the button sum to on. Next, the button A, B, C, and D are randomly pressed, and the counter value T in the LCD screen is incremental when the button is pressed once. And to end up the voting process, the button sum is pressed to sum up the result. The LCD screen will then display the overall result. And that's all. Thank you for watching our video.